Welcome back. This topic is torque. Torque is the tendency of a force to rotate an object about an axis. Only the perpendicular component of the force is used in torque. We use theta to represent the angle between the force and the object. Common examples of torque? Well, they include wrenches. So think of torque as using a wrench. The longer the wrench is, the more easily you can turn a bolt using the same amount of force. Here's a little diagram to highlight this. So we have a little bolt here. Okay, the bolt is right here. Now, if we obviously we know when we're using a wrench, we want to use it at the very edge of the wrench. If we used it here, we wouldn't be able to get as much torque. We'd have to use more force to get the nut to turn, the bolt to turn. If we use the wrench at the very edge, okay, increasing the radius, or what we call the lever arm, we increase the torque. So basically we're rotating about this axis. We think of the bolt as the actual axis. Torque is the tendency of the force that we apply to rotate that bolt or that axis. Now, the longer the wrench, so the longer the lever arm, the more torque we have. If you see in this diagram, if we hold the wrench at a distance of 1 foot from the axis, we have to use a force of 20 pounds. Whereas if we double the lever arm, or double the length of the wrench, we can use half as much force to get as much power. Now, we all know we can't turn this bolt itself on its point with our fingers. We need a wrench. Wrench uses the concept of torque to actually allow us to use less force, less strength to turn this bolt or this nut. Another common example of torque in real life are, well, baseball. In baseball, we know that we want to hit the baseball at the, close to the edge of the baseball bat. In essence, we're creating a lever arm. It's similar to the concept of a wrench. So with the wrench, we want to hit the ball, with the baseball, I should say, with the baseball bat, we want to hit the baseball at the edge, increasing the lever arm, and then thereby increasing the torque. The torque is the force used to basically hit this ball and send it flying out for a home run. Now, two equations that come into play for torque are basically the same equation. So tau equals r, r being the radius. So this is basically the distance from the axis. So distance from axis. So torque is going to be equal to r, the distance from the axis, times F sine theta. F sine theta is basically gives you the perpendicular component of force. Only the perpendicular component of force comes into play. So let's look at this in a little diagram here. Okay, we have a bolt, and we're applying a force. So we're pushing down on the wrench. As we're pushing down on the wrench, the only force that comes into play, it doesn't matter if you come in at this angle, only force that comes into play is this perpendicular component of the force. Therefore, another expression would be tau equals r f and the perpendicular component of f, which is the force that's being applied in providing torque.